Hello humans and welcome to the inside of Mr. Little's computer. You are virtually a part of it now. Basically we're looking at my screen and I have here an amazing little program, Google Maps. I'm sure you've all used it. And we're looking at our planet. We're actually looking at satellite imagery, so pictures taken from way up above us of our planet. And the reason we're looking at this is so that we can investigate the impact of mountain ranges on precipitation patterns. Wow, that's incredible. So we're going to start in North America because we play favorites and that's where we live. So we're actually going to look at Canada though. So all you hockey fans, uh, hopefully you like this. What we're going to look at is the Canadian Rockies. It's a big mountain range. You can see it here, this little white strip. That is actually, oh, I keep zooming in accidentally, sorry. That is actually the tops of mountains, the Canadian Rockies. Darn it, if I zoom in again, I'm going to lose it. So what we have here is a line drawn. This is the edge of a mountain range, and right up in this vicinity, somewhere in here, is about 60 degrees north latitude. It's pretty wet. So you've got all of this weather coming in from west to east. The prevailing westerlies are driving that, and it's very wet in this region due to low air pressure, rising air. And when it hits this mountain range, it has to try climbing up the mountain, and as it tries climbing up this mountain range, it is going to end up getting colder there. We know the temperature drops as we go higher in altitude, and eventually it gets so cold the water condenses. We get these big fat drops and it falls down as rain on this section over here. What doesn't fall as rain ends up falling as snow on the tops of these mountains. So most of our precipitation ends up on, we call this the windward side, the side that the wind is coming from. Woohoo! And over here, oh no, there's no water left up in the sky for this section. This is the leeward side. It has the, ready, here's a trick, least amount of rain, leeward side, least, that's not how you spell least, but that's how we're going to spell it. So it has the least amount of precipitation. The windward side ends up having plenty of precipitation. So I'm going to get rid of my silly pencil writings and we're going to zoom out a bit and actually look at a different part of our planet, which I think is fun to look at because it talks to you about prevailing wind patterns, which we all love to talk about. So this, for those challenged students who don't know their geography, this is South America, and what we're looking at here is the Andes mountain range. Let's go ahead and pull this up here, and I will draw a line along the Andes mountains. Whoosh, this away. Up through here we have, whoops, sorry, I ran out of space on my mouse pad. We have some mountains. The Andes, they get taller as you go down here, but still, very distinct geographic pattern here. We can see it is wet, obviously, on this side over here on the right side, and dry on the left. What in the world is going on with that? Well, let's talk about what the prevailing winds are doing here. We know that this is the equator up here running through Brazil and parts of Peru, and we should also hopefully know that our prevailing winds there, they tried moving towards the equator because the air is rising up here, but everything in the southern hemisphere gets deflected to the left. So basically our prevailing wind patterns end up doing one of these numbers. Whee! Boom, and they slam into this mountain range, right? And all the water that's in them gets leaked out onto the windward side once again. Let's talk about down here. Strange. It's the same continent. Why in the world would it not have the same precipitation patterns? Well, let's look here. Why would the left side be wet over here? Well, at 60 degrees north, down in this vicinity, the very southern part, we end up having rising air again. So air tries to move in here, but it moves towards its left. The air's left, not my screen's left here, but so the prevailing wind patterns end up doing this, and if we draw that over here, you'll see that means the wind in this region is moving from this direction. So again, the windward side of these Andes Mountains is still the one getting all the rain, and the leeward side is dry. So in this vicinity over here, fun fact, we've got about 30 degrees latitude here. So we've got falling air with high air pressure, and we have this mountain range. What you end up with is the driest desert on the planet, the Atacama Desert, and it can receive less than 1 millimeter of rain in a century in some places. I don't know who's standing out there measuring that. They're probably very, very thirsty. I'm going to clear my pencil here, and we're just going to show without so. Oh my goodness, I got to get rid of this pencil, silly pencil. Without as much talking, we're going to show the Himalayas, one of the largest mountain ranges, and zoom in somewhat, and just let us talk a bit about what direction the winds must be moving in this vicinity. Well, here's the mountain range. Pull that up, boom. Here is the mountain range. You can see the white snow-topped mountains. What direction does the wind have to be moving? Hopefully you can answer it at this point. Well, it's dry here. It gets the least amount of rain up here. So it has to be getting wet from down here. So we can, just by looking at this, kind of have a rough estimate as to what direction the wind would be coming from. So it would have to be coming from this vicinity in here, trying to move up past this mountain range, if that is going to be our windward side. So hopefully this gives you a good visual of what's going on our planet in terms of how altitude would affect our altitude would affect our precipitation. And the last thing I'm going to leave you with is this simple thought. This right here, you see how there's like no rain in this big dry region? Oh, they call that a rain shadow. Oh my gosh. Oh my gosh. So picture a giant shadow being made by the mountains where no rain can fall. So sad. I encourage you to explore your Google Maps on your own. Try to investigate, oh my gosh, if I do that again, try to investigate how mountain ranges affect precipitation. Another fun thing to do is to actually just look at the general patterns of precipitation, how it's wet at the equator, dry around 30 degrees. You can see it. You don't even have latitude lines, but you can estimate these latitudes just based on this. So play around with that in Google Maps. If you have the internet, you have Google Maps, so it is quite enjoyable. It's all I do on the weekends. I just sit here and look at Google Maps. All right, enough about me. If you have questions about any of this stuff, ask your science teacher. Peace out, students.